Okay, now let us move ahead. We need to now ask a question. I am going to build up a crossbar for n by n size, and of course whether I use complete all the cross points or I use the lower half triangle or upper half triangle does not matter. My complexity of the cross points is O(n) square. Okay. Now question is, and of course there is one fundamental property which I have told earlier, that it is a strictly non-blocking system. So what does that actually mean? If this is input and this is output of the switch, if an input is free, if an output is free, irrespective of whatever other connections are made, without disturbing those connections I can always connect these free input and output. Okay. That is what the strictly non-blocking actually means, and that is a fundamental property of a crossbar. Okay. And the complexity is this. Now my problem is, if I keep on increasing my switch size, I go from 10 to 100, 100 to 1000, 1000 to 10,000 and so on, my number of cross points which are required are growing at n square rate, which is pretty large. So users have to pay a huge amount of cost per connection as my switch size actually grows. So how to take care of this situation? Can I reduce my cross point complexity while maintaining the strictly non-blocking property? That is a question. And of course that is one thing which I desire. Secondly, can I increase this size to arbitrarily very large values? Okay, people should ask why not, probably we can do that, but you have to understand that all these cross points have to be controlled by a controller, and mostly there will be one controller per crossbar. So whenever a connection request will come, it will process, it will set up a connection. It does take some computing load. So as my size actually grows, my computing load also grows, for which will be managing the cross points. So after certain size, if you start increasing size to a very large value, this controller which is going to control the cross point will not be able to take up the load. So you cannot arbitrarily increase your size has to be limited. Okay. So because I cannot go arbitrarily very large, I still require a strictly non-blocking property. Of course later on I will tell you that actually it is theoretically fine, but in real life situations I will probably live with some small blocking probability, but I should know that what is that amount. Okay. So maybe how we can do this. So idea is that let us use smaller crossbars and put lot of them together to build up a larger one, not a larger crossbar but a larger switch, which will still retain the same property of strictly non-blocking nature. Okay. So maybe how this can be done. So we can create something called multi-stage interconnection network, MIN. So that is what I am now introducing. So the way it will be done, there will be not one, there will be multiple stages. So I will put my lot of crossbars in one stage, I will create another stage, I can actually have any number of stages. I can put another one, I can add any number of stages. Only important thing is that all my inputs are coming here in the first stage, and all my outputs will be emanating from the last stage. And of course I also need to ensure certain things. For example, I cannot leave a port free here. All the ports here should be connected to all the incoming ports here. So this is important. How this will be done is a design problem, how to do it. We will actually discuss these as we go along. And so means no input port, no output port is free here, no input port is free here, all output ports here have to be connected to some input port on this side. and so on. Only these will become output ports, these will be the input port. That is a multi-stage interconnection network. Now, idea is that we still do not know how many stages will be required. I want a strictly non-blocking switch. I only know this basic building block is a crossbar, so it is in itself is a strictly non-blocking. So, I have to not talk about this network which has to be strictly non-blocking. So, can we do it with 2 stages? Let us ask this question. So, let us try if we can do this. So, I am going to build up a very simple switch and see if I can get a strictly non-blocking switch or not. So, let me put up I am now putting a small n here, okay, and 2 of them. So, probably I want to build up a 2n by 2n strictly non-blocking switch using n by n, a small n by n crossbars, and I am going to put them in 2 stages. Let me try it with 2 stages if this can be done. So, there are n outputs here, there are n outputs here. Now, how to connect in between? Of course, most common sense logic says because any input should be able to connect to any one of these outputs, I should connect this switch to any one of these. There are only n outputs coming here, so I can take n by 2 this side and n by 2 on this side. Same thing I can do here. Wow, I got a 2n by 2n switch, but is it strictly non-blocking? So, how to find it out? See, remember my condition was that an input is free, an output is free, I should not disturb any existing connection and should be able to make a connection between them. So, if I can create a situation where it is not possible, to set up a connection when input and output both are free, then I will say this is a blocking system, this is not a strictly non-blocking switch, and henceforth this arrangement is not going to work. So, let us see how I can do this. So, let us take n by 2 of these connections, they are connected to n by 2 here in whatever pattern. So, I can, all these lines are busy. Now, there is one input which is free, one output which is free, I want to connect these two. How to do this? All the n by 2 are already occupied. If I use bottom line, I cannot come back here, there is no way I can set up a connection. So, I have shown that by one example that this is not a strictly non-blocking switch, this is a blocking system. So, with 2 stage it is impossible to build up a strictly non-blocking system, okay. And of course, for this 2n by 2n, my cross point complexity is actually 4 into n square for a 2n by 2n system. There are 4 such switches. Of course, cross point complexity turn out to be 4n square here also. So, same cross point complexity, but I ended up in a blocking system. But I can generalize with 2n by 2n, it turns out to be same. But if I make it k such elements, so 1 to k, there are many such things. So, I am actually dividing this, will not be n by 2, this will be n by k. So, many n by k's will be there, so all of them will become n by k. So, total thing will be k into so k n k, that will be the total number of ports. The ports on this side will be n k. So, when you build up n k by n k switch, you require n square k square number of cross points. When you have 2 stage kind of network, I have 2k n by n switch, so n square. So, these many cross points will be required, and this will be a blocking system. Both switches are actually nk by nk. both switches are Nk by Nk, but if I build up a single crossbar with Nk here and Nk here, I have these many cross points will be required. If I build up a system like this, I need these many cross points. It is actually reduced by factor of k. Okay. So you actually multiply by 2, k by 2 essentially, it is reduced by factor of k by 2. So if you divide by k by 2, you will end up in this. You require less cross points obviously, but you are losing your restricted non-blocking property. Can I make it into a strictly non-blocking system still? And using smaller blocks, remember even if I do that, I require multiple CPUs. So there will be a separate controller for each one of these switch blocks. I will be requiring one control block, one CPU which will be heavily loaded. Here CPU load will get distributed, at least it will become a distributed system. So if we do that, how this can be done? So we have to actually come out of the notion that I can build up a crossbar of n by n only. No, in general I can build up a crossbar of n by k also. So I want to build up a 4 by 8, I will have 4 input lines and I will have 8 output lines. But remember, if it is a 1-to-1 connection, only 4 of these output lines will be occupied at any point of time. But this is 4 by 8 crossbar. So if I can do that, in worst case, all these small n number of lines has to connect to this. The way it has to be done is, if I want a strictly non-blocking system, with 2-stage interconnection, I will take n as inputs, I will take kn as the output. So number of outputs I will increase because I can make 4 by 8, I can also make n by kn and I can do multiple of them. So k such units, and similarly I will have in the second stage also similar units. So since they are kn, so I will be taking n here and to the last guy, and same we will be doing n here, and of course to all intermediate stuff. So if all n connections are required to be done here, I can always do it. It is a strictly non-blocking system, but number of cross points which will be required is now n into kn into k such switches, and 2 of the 2 stages will be there. You will end up in 2 n square k square, twice the number what is required by a single crossbar. You do not gain anything in terms of the cross point complexity, you only gain in terms of using a smaller multiple controllers, multiple separate CPUs which will be controlling. So your computing load gets distributed, which is setting up the connection, which is dismantling the connection. But we can actually further improve on this. What we will do is, we need to essentially now discuss one more important point before we move ahead. In real life situation, as I mentioned, I do not need a strictly non-blocking property, because I might have to put tremendous amount of hardware to create a strictly non-blocking property. But do we want this kind of situation, VIP treatment for everybody? I might be happy if I want to make a call, it does not go through once in 10 years or once in a year, it is okay. I will wait again and make an attempt. So I will most of the real life situations will actually have a blocking switches, because my cost goes down drastically. Okay, my amount of hardware requirement goes down drastically, and the performance, maybe 1 in 10,000 calls or 1 in 1,000 calls will get blocked, and I have to attempt again after some time. which is acceptable to as a user, because it is going to reduce my cost. If I want every call should go through immediately, then my cost is going to be huge in setting up of the system. And even if you want a strictly non-blocking switch, there will be situations when you will not, your call will not be able to go through. That will happen when the destination is already busy, is already occupied, and you cannot connect to him because he is busy. So there will be very small probability even for that. So we accept this degradation in slight degradation in service, which reduce a which leads to reduction in lot of cost for us. So now it is important that I have to now go to a situation. So 2 stage will not work, so I will try to go with 3 stages, and then we will try to make an estimate that what is a blocking probability, because I do not want a strictly non-blocking switch, I want a blocking system. So we will look into how to estimate the blocking probabilities in the next week, the lectures which will be given in the next week.